Good morning, children. So, children, we are coming to the end of chapter Electric Current and its Effect. And today, we are going to cover the last topic, Electric Bell. We are going to discuss this topic under two headings, parts of an electric bell and working of an electric bell. Children, electric bell is a direct application of an electromagnet. Now, coming to the parts, first one is electromagnet. Now, this iron rod, which is shaped in the form of capital letter U, has two wooden reels. In between these two wooden reels, there are present large number of copper turnings of copper wire present around the two ends of this electromagnet. One end of the copper wire is connected to this brass stud. Other end of the copper wire is connected to the terminal T1 and through push button it is connected to the positive terminal of the cell. Coming to the next part, armature. This blue colored one is armature, which is an iron bar, and this armature is then connected to the contact spring. Children, this yellow one is the contact spring by means of these studs. This armature then ends into a hammer which is made up of steel. This hammer strikes the gong when you push the button. Coming to the next part, contact spring. This contact spring is made up of steel which is also inclined, and at a point A, this contact spring is connected to contact screw adjustment. At the other end, now one more important thing, this contact spring is then connected to the armature by means of these screws. Coming to the next, contact screw adjustment. This contact screw is in the form of a brass pillar which also has a screw made up of brass. Through this brass pillar, the copper wire is connected to terminal T2. From terminal T2, it is connected to the negative terminal of the cell. Now children, this tip of the contact screw is in contact with the spring, and this is made up of a special alloy whose composition consists of silver and cadmium. Coming to hammer and gong. Hammer is a brass or the circular object which you can see on the wooden board where the electric bell is fitted, and then it is made up of brass, and then we have a hammer which is made up of steel. When you push the button, this hammer strikes the gong and you can hear the bell ringing. Now let us see the working of an electric bell. Now children, see, when you push the button, current starts flowing through this circuit. It comes to terminal T1. From terminal T1, the current comes to this copper coil. The moment current comes to the copper coil, this iron rod starts behaving as an electromagnet. Now, since it is connected to the brass screw to the spring, now this, you know that armature is also made up of steel. This electromagnet, due to flow of electric current, will now attract armature. As a result of this armature will come closer to the electromagnet. Now, since this armature is connected to the spring, there develops a tension in the spring. And when this armature comes closer to the electromagnet, now since this armature is connected to the hammer, this hammer strikes the gong, you can hear the bell ringing. Now, since this armature is also connected to the spring, so when armature moves closer to the electromagnet, this ready. Now, the moment this gap develops, what happens? Circuit changes into an open circuit. Current stops flowing. The moment current stops flowing, you can see that this iron bar now stops behaving as an electromagnet. Now armature will come back to its original position. This contact spring again comes back to the contact screw and the hammer moves back to its original position. And why all this happened? Because now the current has stopped flowing through the circuit and now the bell is ready for second round of ringing. I hope children parts of an electric bell and how does it work must be clear to you. Now children, you are going to see a PPT which will make this concept more clear to you, because I think that at this point with this circuit diagram you may find it difficult, but once you observe the PPT, the working and the parts will be more clear to you. Okay children, I hope you enjoyed the class. Thank you.
In this PPT, we are going to see what is an electric bell, what are the parts of an electric bell, what is the circuit diagram, and what is the working of an electric bell. An electric bell is a mechanical bell that functions by means of an electromagnet when electric current is applied. It produces a repetitive buzzing or clanging sound. Electric bells have been widely used at railroad crossing, in telephones, fire alarms. Coming to the parts of an electric bell has following parts: electromagnet, armature, contact spring, contact screw adjustment, hammer and gong. Coming to the parts, an electromagnet is a soft iron rod that is bent in the form of U, and on each of its arms is mounted a wooden reel. Around each of the reel is wound an insulated copper wire of a large number of turns. One end of the copper wire is connected to the terminal T1 and the other end to the brass stud S. Armature is a soft iron bar suspended from stud S with the help of a flat spring such that the armature faces the poles of the electromagnet. Coming to contact spring, it is a flat steel spring slightly bent and fixed to the armature with the help of screws. At the other end of the spring is attached a contact point which is made up of silver cadmium alloy. This alloy does not get oxidized easily due to sparking. Coming to the fourth part, contact screw adjustment. It consists of a brass pillar through which passes a brass screw. The tip of the screw is made up of silver cadmium alloy so as to prevent the oxidation due to sparking. The contact screw adjustment can alter the frequency of ringing bell. The brass pillar is connected to terminal T2 by a copper wire. Coming to the next part, hammer and gong. The hammer is made up of steel and is attached to the armature. The gong is made up of brass. When the bell operates, the hammer repeatedly strikes against the gong, thereby producing sound. Here in situation 1, hammer is away from gong, so sound is not produced. In situation 2, hammer is hitting gong, resulting in sound. Now let us see what is the working of an electric bell. Now, terminals T1 and T2 of the bell are connected to a battery through a push button switch. When the push button switch is pressed, the electric current flows from the battery to the electromagnet and then to the contact screw and finally to the terminal T2 and again to the dry cell. Thus, the electric circuit is completed. Now, following effects take place simultaneously as the electric current flows through the coil. Number 1. The electromagnet gets activated and pulls the soft iron armature strongly towards itself. The spring connecting the armature and the stud S gets under tension. The hammer strikes against the gong and produces sound. The electric circuit breaks at the contact points, but the armature and the hammer continue moving towards the electromagnet due to the force picked up by them. Now, as the electric circuit breaks, the electromagnet gets demagnetized. Thus, it cannot hold the armature. At this point, the spring, which is under tension, brings the armature back to its original position. However, as the armature returns to the original position, the electric contact is re-established. Thus, the armature is again attracted towards the electromagnet. So children, in this way, a rapid make and break of the electric circuit takes place and the hammer hits against the gong, producing a familiar sound. I hope children, the working and parts of an electric bell by now must be clear to you. Thank you.